So in this video, I'm going to talk about the different types of functional groups associated with chemistry. And so functional groups allow you to predict how a molecule is going to react. And so if it has a certain functional group, that functional group will behave in pretty much the same way on every molecule. So it's a good generalization for how it's going to react. And so we'll start with alcohols. And alcohols are characterized by the OH group, or also known as hydroxyl. And so an example would be maybe something like that, or something like that, or something like this. And here the H's are implied. And so those would all be alcohols. Essentially, anytime you see an OH, actually that's not always true because it could be a carboxylic acid. But if it has an OH, it's either a carboxylic acid or an alcohol. And we'll talk about how to spot the difference between that. And so a carboxylic acid, actually I'll talk about that in a little bit. And so the next functional group we have is called ethers. And so this has an oxygen bonded to two alkyl groups. And so lone pairs there. And so the R can represent, these aren't the same, so R1 and R2, for example, they could represent anything really, hydrogen or a carbon, whatever. Actually, in this case, an ether, the R would not represent a hydrogen, or else that would be an alcohol. And so some examples are that would be an ether. You could have a cyclic ether. You could have an ether like this, and lone pairs on all of the oxygens. And so those are ethers. So remember, two alkyl groups. And so next, we're going to talk about aldehydes and ketones. So aldehydes and ketones. And so they're really similar. They're characterized both by a carbonyl group, carbonyl, which is a C double bonded to an O. That's the carbonyl group. And so, for example, an aldehyde has a C double bond O, and then an alkyl group, and then an H. So this H is the difference between an aldehyde and a ketone, because a ketone has a C double bond O and two R groups. So this could be different or the same, R1, R2. And so that's the key difference here, is an aldehyde has a hydrogen. So an aldehyde has an H in it, in the name, and so think of a hydrogen coming off of a carbonyl. And so maybe an example of that could be O CH3H, and then a ketone could be something like O CH3 CH3. Really simple. And so next we're going to talk about a carboxylic acid. And so it's pretty similar, it looks pretty similar to an aldehyde and a ketone. So carboxylic acid. And so here it has a carboxyl group, and so you'll have an O, C, here's an R, and then an OH. So some people get that mixed up for an alcohol, but the thing is, if you have an OH bonded to a carbonyl, which is this thing, then it's a carboxylic acid. So whenever you see an OH, always look for a carbonyl next to it. If it doesn't have that, then it's an alcohol. If it has a carbonyl, which is a C double bond O, then it would be a carboxylic acid. And so an example could be O, CH3, CH3, and then OH, CH2, CH3, sorry. And another one could be OH, something like that. And so there are a couple of carboxylic acid derivatives. They're pretty similar. They all have carbonyls. And so I'll just draw them out really quick for you. So this, a chlorine, if it has a chlorine there, in that location, it's an acid chloride. And what if we replace that with an O and then another R? And so some people might get this mixed up for an ether, but remember the carbon here is a carbonyl, so if that occurs, that's an ester, not an ether. And once again, the R's could be different. And then finally, you have oxygen, R group, nitrogen, Z. Here we use Z to represent either an R, which is an alkyl group, or a hydrogen. And so this is called an amide. And so an amide has a nitrogen in it bonded to a carbonyl, and so that contrasts with an amine. An amine does not have that carbonyl there, so the nitrogen, it could be something like this. With the lone pair, it would be that. There would be no carbonyl. Or, like, the H's could be replaced by alkyl groups. So, for example, it could be that would be an amine too. And then there's primary, secondary, and tertiary. And so that just designates the number of carbons coming off of it. And finally, the last important group we're going to talk about is the cyano group. And so you have something bonded to it, a C triple bonded to a nitrogen. So that triple bond is important. And so the C triple bond N, if it helps you remember it better, is also found in cyanide, which is a highly toxic substance that was also in the James Bond movie, if you guys watched that. And so that pretty much summarizes the functional groups. And if you like this video, if it helped you, please feel free to like, comment, and share this video. And subscribe if you haven't already.